the first, yeah. Jakub is a big believer in WASI and is involved in many activities related to WebAssembly in general, from being a maintainer to WASM to participating in the WebAssembly community group. He's also a Rust programmer and started getting serious with Zig a few months ago. I think that the story is that one day he was compiling a Rust project when he discovered Zig. And by the time Rust had finished compiling, he had already learned Zig and sent his first pull request to add WASI support to the Zig standard library. Maybe it's true, maybe I just made that up. Anyway, the talk is Zig loves WASI, and Jakub, the stream is yours.
Thanks. So hello everyone. That was a great introduction actually, and no, it was not made up. Right. So as Christoph said, I'm one of the maintainers of WASM, and hopefully you're going to enjoy this. So I'm happy to actually announce that we have CI coverage basically of WASI and Zig. So there's a couple of rough edges to sound off still, but majority of stuff actually compiles and works fine. Right. So without further ado, let's keep going. So I should probably mention that this is the first time I'm actually using hand-drawn slides. So I'm not really an artist. So if anything looks funky, sorry about that. This is largely inspired by a very dear colleague of mine, Lynn Clark. You probably heard of her if you're interested in WASI in general. She's a great artist, and she's obviously fantastic when it comes to drawing code cartoons. So this is basically like to honor her, I guess, inspired by her. Right. So what is WASI? Basically, to give some more insight into it before we go into Zig. Basically, if you have your WASM module and you connect it with certain syscalls, you can and give some capabilities, then you can actually stick it into WASI runtime, such as WASM, and then this is going to sanitize everything and give you some safe comms with the host. So in a way, it's pretty cool because it's portable, but at the same time it's safe. So it takes WASM, which already has some safety features baked in for like memory access and stuff like this, and now also gives you this system safety in the sense that you opening like current working directory doesn't really make much sense in WASI. Plus, actually to open anything, you have to be given a pre-open or capability from the user. Okay, so and this is basically the capability here. All the examples will be with respect to the something like current working directory, which is basically here, and we'll see how it works. So basically, I'll show you in a minute how actually you can write this stuff out. Before we get there, let's have a quick look at how everything is tied, basically connected together inside WASI and how it translates into actual syscalls. So all the code samples will be in Zig, obviously. So basically, if you have your WASM module and you write to debug warn, for instance, then that underneath translates into an import, which we basically take from the runtime itself, fd write, where we actually target the stood out, which in this case is number one, like I guess in all the POSIX systems, plus the buffer with the actual bytes in it to actually write to the screen. Now we then put that into the runtime, and then the runtime actually checks whether we actually can do that, and then outputs that in the screen. Okay, so it's very straightforward. Now I'm just going to prove to you that it actually works. It used to work before, but just to show you some stuff. So I do a lot of live coding. Hopefully you guys can see it. So all of this stuff is done using the latest nightly build. So everything should work. If you get a nightly compiler, everything should work fine. So let's open this. Go to main Zig. I'm not going to attach this. So basically, everything is actually done here for us. I'm just going to show you that everything builds fine. And actually, really fast. I love it about Zig. Really good. Okay. So the stuff actually lands in the cache by default. Oh, pardon me. And then hello WASM, and there we go. Okay, and to demonstrate, actually with WASM, it's pretty cool because you get something like an S-trace for free. So you can, if you're developing any WASI-based app, you can actually very quickly have a look if all the syscalls that you thought you're going to call are actually called. So you can do that with some logging enabled. The library that's responsible for the syscalls is called WASI common. So we just enable the trace, and there we go, right? And I was saying about fd write, and there you go. So actually fd write is being called. Yeah, and I think I made him, because this is actually stu debug Warren is outputting to stu there. So I made a mistake. It should be actually file descriptor number 2, not 1 in the slide. But anyway, so everything works fine. So let's go back to the slides. So if I'm talking a bit fast, I have quite a bit of stuff to cover, and I want to cover everything. I actually want to make. I would love to actually be on the Showtime a couple more times to actually expand on everything. Perhaps even delve a bit deeper in what's actually going on in Zig's libstud, how we actually handle the pre-opens. But anyway, so how can we now access the files in a directory? So using Zig in WASI. And this is really cool, the way we handle that in Zig, because I think it's unique. I don't think any other language, including Rust, actually does it the same way. And this kind of follows from the basic fundamental assumptions, principles, I guess, of Zig, in the sense that everything is meant to be explicit, including allocators, right? We don't have anything default. So you have the power to actually specify anything you want. And the same is actually for getting pre-opened. So anyway, if you call something like this now, and if you want to open something in directory here, then you will probably be met with, capability insufficient, some kind of an error. You can't do this, because of the safety features of WASI, we need to actually pass in a pre-opened directory somehow. So how do you do this? And it's pretty simple. However, it's quite tedious. So if we could actually do that with the bare syscalls, but that it's really tedious. You have to handle the null values, and then you have to iterate until you get all of them. So the idea was to give you guys, if you want to write something in Zig, something like an array list that you can basically use to get all the stuff out in a nice, kind of like more automatic, I guess, way. So basically, we query the runtime using the fd preset get, fd preset their name. We do it in a loop. Then the runtime basically gives us like, hey, this might be a pre-open, but you have to check yourself if there was an error value or not. If there wasn't, then just take it, and that's one of them. Okay. So sorry. Right. So let's do that. So I'm going to get rid of the hello. We don't need that anymore. And let's make, pre-opens. So it's there. Right. So again, init is a perfect, right. So it's going to be pretty simple. All we're going to do, I'm not actually going to do all the error checking. So you guys should do it yourself if you want to be perfectly valid and proper. So what we're going to do here is basically use the default page allocator. We're going to get the args passed in from the user space into our program, which will include the input file. Then we are going to open it and then read the contents and just print it to the screen. Okay, it's very simple. So right, I'm just going to import some stuff so that I don't have to do it later on. The full. Okay, we're going to need fs as well. Actually, get a there handle. And right. So the thing for WASI, for getting the pre-opens, is in fs WASI, so fs/WASI module, and it's called a pre-open list. Anything else? I don't think so. Right. So first of all, let's get the arguments out. Oh, that should be pretty straightforward. Clean up. Free. And then we have allocator. Right. Okay. Then we're going to get the input file name, which will be, pardon me, second argument. I'm not actually checking whether we actually overflowing the array here, but you should probably do that. I'm just going to allow it panic and stuff. Okay, what else? Right, and then we're going to actually initialize the pre-opens. So init with an allocator. Then we want to actually clean it up later on. Right, and actually it's as simple as calling pre-opens populate. Oh, pardon me. Right, so this will actually do all this looping that I described before for you. And it will fetch all of the pre-opens, which you can basically access by name. Obviously, the API here is a bit unstable. This is going to be evolving, but anyway, it's functional as it is now. And yeah, I think the master branch already has some examples in the Zig documentation, so you can actually follow the stuff there as well. Plus, I'll if there's going to be interest, I can also like paste a link to a simple WASI tutorial that covers a little bit more than this that I created a while ago as well. So what's so unique about this approach compared to approach like done in C or Rust is the fact that in C and Rust, because so they have those defaults like default allocator and things like this, fetching the pre-opens is actually done for you in the CTOR. So basically, when you have where you have the entry point, this is where when you actually create the stuff, the where you spin the WASI module, the pre-opens are actually fetched for you automatically once at init, basically. Whereas in Zig, you have to do it automatically. And because of this, I'm pretty sure you can actually experience some undefined behavior because we could, in principle, call pre-opens populate a couple of times. And I'm not sure how we actually handle that in any of the runtimes or if we do at all. So that's pretty cool. It gives you a lot of freedom. If you don't want to fetch the pre-opens, you don't have to include that in your code. And I guess this is why I really like Zig. You have to be so explicit about stuff, and it makes you think about all this stuff like allocs. And in case of WASI, actually, whether you want the pre-opens or not. Right, but anyway, so let's get something like CWD. So in this case, it's going to be pre-opens fine, and then by name. And if it's not there, we're just going to make an outright panning like, oh no. Okay, and with this, we can actually make there. Get the there handle, and we can actually open stuff. So for me, still not good when it comes to actually remembering everything that's going on in the libstud. So and then open the file. Just for reading, we don't need to do anything fancy. And it's going to be input fan. Obviously, the far closing it. Okay, so that should give us the file, and then we can basically get all the contents. And I should thank actually the Orminator here, give you some hints that if you can do that in one line, which I didn't know about before. So and the max we can actually handle here is view size. Whoop, I mean to catch the errors. Right, okay, so that should give us the contents, and then all we need to do now is actually print it out. So oops. Okay, I think that should be it. We'll see if I actually made any mistakes or not. Right. Okay, cool. Right, so let's try it just to demonstrate WASI and how you actually have to pass in the capabilities to actually open anything. Let's try this without anything. Okay, so I haven't actually created, okay, oh no, because we don't have the pre-opens. But first of all, let me, yeah, so actually I'm using new shell, by the way, guys. It's got very, I guess for a person who actually doing a lot of POSIX, learned everything about Linux or used Linux for majority of his lifetime actually Unix. Actually doing piping is quite tricky. But anyway, we have height. Okay, so let's try it again. Still doesn't work. So basically, we have to give it a pre-open. One way of actually doing it is with the flag there, here, and there we go. So we can actually modify this just to show you that it still works. Okay. And as I mentioned before, as another bonus, we can actually have a look what's going on behind the scenes. There's actually quite a bit of this, so I'm not going to go through it. But anyway, I actually encourage you to look through this stuff. You can see how everything is wired up. Okay, so perfect, that worked. And I think that's it for now. I think was I a bit fast? No, I think I made it just in time. So if you want to learn more about WASI, and I sparked your interest, I encourage you to have a look at Lynn Clark's excellent blog post that was standardizing WASI. I did kind of try writing down the shortened link, but basically if you Google standardizing WASI, you should find it. It's #1 hit, I'm pretty sure. It's a great post. It describes the general ideas in a very clear way. And I'm pretty sure from there you can find your way around other stuff. Like you can have a look at code WASI. I encourage you to actually explore the stud library in Zig and how we actually do this stuff. And if you don't want to, I hope to actually talk about this in one of the future episodes as well. So yeah, thank you. So any questions?
Thank you very much, Jakub. Yeah, give me a second. We're gonna move
sure.
immediately to the Q&A view. So that was an awesome presentation. Thank you very much. It's great, and I also appreciate the effort that you put into making sure that it's short, and I think it was also very useful. This shows people how to actually produce a WASM executable that works and does stuff. That's awesome. Let me just give a reminder to the people watching. If you want to ask a question to Jakub, please write it in chat. Remember to tag me so that it's easier for me to notice your message. And also remember that if you are on Discord or the Zig IRC channel, you can also write your question there. I will be able to see it. Although, actually, let me double check. I am now in the IRC channel. So from now, I will be able to see your messages. Jakub, first question, as is tradition, how did you discover Zig, and how long ago was that?
Ooh, that's a good question. I think the first time I heard about Zig was about a year ago, maybe a bit more. And it was I didn't really, so I didn't look that close. I knew it was cool, but I was basically I was preoccupied with Rust and WASM and WASI, so I didn't really have time to dig in any deeper. And then, funnily enough, a friend of mine basically convinced me that we do too many examples that target WASI are done in Rust. And I see what he meant. It is true that majority of guys actually, I guess because it was a spin-off from Mozilla, right? Mozilla is the main company that actually does the standardization work. And I love Rust as well. I love Zig as well. So I started looking like, hey, what about Zig? And then I remember I had a quick chat with Andrew, and I was like, hey, would it be of any help if I started, contributing something, like WASI related to Zig? And he said, yeah, it's actually pretty easy because we don't have any tests, so you can't break anything. I was like, okay, cool. Well, let's see how it goes. So there you go. So this is how it all started, and now I started basically. I'm kind of exploring everything about Zig itself. So a bit more about compiler internals, all the way to the libstud and applications.
I see.
It's a lot of fun.
Yeah, it makes a lot of sense. I can see from your point of view both why Rust kind of is the dominating language in this space, and also why you also might want to have examples, like diversified examples a little bit. But you already so the code that you were showing, right? Just to make sure everybody understands, this was contributed by you, right? The integration with everything else, like the pre-opens and everything else, that's basically you are presenting your interface that you added to the language. Yeah, that's right. And I encourage people to actually start using it so that they can break it and report some bugs so you can actually improve it. Okay, that would be awesome. Because it's like the first draft, right? So obviously it's going to evolve. So we have one question that I think you can answer very easily, just to clarify the point that we are also discussing about just now. So the first question is, have you thought about using Rust code through FFI for this, or is this pure in pure Zig only?
Oh no, this is pure Zig. So basically, when I started looking at Zig and how it works, one of the things that I really like about the fundamental assumptions is the fact that you can actually build anything without linking with libc or anything like this. Because actually, in Rust itself, so basically, the way it's done, Rust links with WASI libc to actually do this stuff, and that was one of the possibilities here as well. But as I said, it actually makes certain assumptions, such as the pre-opens being computed for you up front. It's useful because you don't have to worry about this, but at the same time, it's quite limiting, especially for Ziguanas, I guess, right? Because in Zig, you want to have control over as much as as possibly you can, and this is one of the things. And as I said, this is this exciting thing that you can actually do the pre-opens yourself whenever you want. I haven't done this, but I'm as I said before, try experimenting with this. Try actually calling the pre-opens a couple of times, especially when you add some stuff in. And then later on, this will prove very useful when actually WASI and the runtimes actually catch up. And we will have the possibility of actually adding the pre-opens perhaps afterwards. So not only when you spin the app, but maybe later on. So if you have like a reactor model or something like this, then you will obviously want to be able to fetch the pre-opens at a later point. And we'll see how it goes. So
the next question is, what kind of allocator interface does WASI define? Is it malloc and free?
So in this case, actually, I'm not quite sure. So we have only page allocator as far as I know, and this is basically based on the two intrinsics that. So basically, every page in WASI, as far as I remember, is 65K. And the default, basically the easiest way to interface with this stuff is using the page allocator that we have defined in Zig. And that's basically, this is calling two intrinsics whenever you run out of memory. So this is grow memory, I think, or memory grow, and then memory get, I think. Maybe it was something else. I can't remember. I actually added some helper functions for this like recently, but I can't remember the names of the intrinsics. But anyway, it's based on this. And I'm pretty sure we're still missing like a more like I don't know how to call it, like a better allocator for WASI. We only have this page allocator by default, or you can use anything else that we have in the libstd as well.
Mm-hmm.
But there is no, you have to write it yourself. There is no like the runtime doesn't provide like malloc and free, so you have to do yourself. The only thing you can do is ask the runtime to actually give you more pages of memory.
Okay, so it's very basic. And by the way, on the topic of memory allocators, so Andrew is noting in the chat that the page allocator for WASM was written by Feng B. And we're gonna come back to this topic after the talks, closer to the end of the show.
Cool.
But yeah, makes total sense to have the let's say more refined allocation strategy written inside Zig.
Yeah, for sure.
So another question is, does the same code work in the browser via WASM?
That's an excellent question. So yes and no. So basically, it is possible. How to put it? So basically, if you compile to WASM32 WASI, then you can actually take that code and compile this into Emscripten. So it's like this double compilation thing. And this could then, well, no, I'm talking crap, sorry. So basically, if you take your WASI module, but then all you have to do is compile something like WASI comma to Emscripten. So basically, that would be your host, and then you can run that in the browser. So that I think that was the original plan, for WASI modules to be runnable in the web as well. And as far as I remember, they would be like it has to be done via Emscripten to have the like the JS layers, so the memory file system and everything rolled out for you. We had something like this in WASM-time, but it's quite dated. It's been done a long time ago, when I think basically the syscall code was written still in C. I had a stab and I'm actually rewriting that, so basically redoing this with the latest version of WASI Common, but it's not actually progressed anywhere yet. So I had some draft, but I haven't finished it yet. So, but in principle, that's the idea. It's the idea that you compile it once, you compile it to WASM32 WASI, and then the browser version. So, for example, Emscripten will be smart enough to hook up all the syscalls, and that's already there as far as I remember. You can actually compile that. You should be able to compile this stuff to Emscripten, like the runtime bits.
I see. So just to make sure I understood, so you're saying that even opening files and all the system interface stuff, maybe not today, but is planned to be supported also by the browser itself.
Right, but then how and what the file is, that's up to the browser, right? If it's going to be in memory, or if it's going to open up some kind of a tunnel to the host, not sure. Probably not. That's probably not the safest, because that's the whole point of WASI, right? That you don't want to do that.
Right. So maybe, well, you tell me how good of a high level, super imprecise way of understanding this is. It's still WASM, but WASM-time is kind of like Node.js, while you can also run the same WASM in the browser, but then you don't have access to. It's not exactly the same, just as it's not exactly the same for having a JavaScript library for the browser versus for Node.js.
Right. So yeah, kind of, because so basically the WASM itself. So if you compile to WASM freestanding, all you get is the code translated into WASM ISA, and that's it. Nothing less, nothing more. So you don't specify an import, you don't specify any exports. Well, you could specify your exports, right? But you don't have any imports. And then WASI, all that WASI does is basically, if you specify certain imports, such as FD write and stuff. So you say that, hey, I expect this to be external, I expect that to be provided to me from somewhere. Then you can actually interface with the WASM-time, for instance, as a runtime.
Okay.
And Emscripten does the same thing, but I think it's got way more syscalls, and it actually emulates the entire Linux stack. So it's quite complicated, and that's why WASI was invented, because I think you get like only 50 syscalls or something, whereas I think in total on Linux it's over 350, as far as I remember. I don't know for sure, but it's a lot. So easy to make a mistake and open yourself up to an attack and stuff. So.
There's another question. This one is from Andrew. So hi, Jakub. Can you give us an idea of your vision for the future of the Zig project and WASI?
So I hope for that's an excellent question. So thank you. Oh, some crap here. Sorry. So I hope for Zig to be on par with Rust. I'm not sure how we're gonna do it yet. There are some things that are common to WASM and WASI as far as spec is concerned, like interface types. I'm pretty sure we'll be able to work it out, but I really want Zig to be on par with Rust. So basically, basically, if you have in mind, hey, I want to write something for WASI, you're gonna have in your mind Rust and Zig, and obviously C, because it has to be there. But I would love for it to be either Rust or Zig, and that's it. I love the safety features of Zig as well. It's pretty well thought out. I love the stuff they actually have to, as I was saying before, be explicit about allocators and stuff. So yeah. And it's so easy to cross-compile anyway, so that would be a perfect match. Oh, yeah. Right, sorry. And one more thing, I forgot about this, and this is actually what Andrew reminded me ages ago, that when he and other guys were designing the libstud, he had this stuff in mind already. So that's perfect. What I mean by this is that notice that majority of stuff, or actually everything, except for the absolute paths, obviously, is done with a dir handle and a relative path. And that's exactly what WASI is trying to accomplish, is that we kind of forget this faulty notion of actually everything is a string, like they do in C, and you have everything path-oriented in the sense that you specify a path, like an absolute path, and then you then find it for having a handle and then a relative path. And we add some safety features on top, such as you can't actually escape beyond the pre-open. So I think in that respect, Zig is perfect.
Awesome. So let's see. I think there's another couple of questions, but first I'm gonna ask actually one that I had. So I was playing around with the event loop integration around the standard library in the last few days, and I saw some of the code that I'm guessing you contributed about. Like there's basically a bunch of switches and if statements that that get resolved at compile time, and based whether you are on Windows, on Linux, or WASM WASI. There's different paths that do different things whenever you try to open a file, do network activity, etc. And I saw that since I was looking around for event loop related stuff, I saw that there is no async support, no evented IO support for WASM. What's the state of this? Is this being discussed? Do you know if what will be the feature behind, the philosophy behind the API? So
it is discussed. No work, as far as I know, has been done yet, but it's definitely on the radar. So it has to be supported, and it will be. So you'll be, as far as I remember, the consensus was that you'll be able to either, you have like both async and sync versions of the same syscalls, as far as I remember. It might have changed, but basically async is number one, and it's definitely on the radar. It's not, it's not there yet though. There's a couple of things missing as far as I know. Andrew rightly pointed out that actually you can do async stuff with single threaded model only as well, and that's true. Node is doing that, of course, but in terms of like WASI itself, we don't have anything there yet. But when it's actually, when we do some stuff and it lands, then I'll be sure to mention that in Zig as well, so that we have so that we have full async support in the libstd as well.
Okay, awesome.
WASI, of course,
yeah, I'm looking forward to that. Or more precisely, I'm looking forward to somebody else do that work, not me, actually. So, two final questions. One is, what is or is going to be the relationship between WASI and WebGPU? Do you know anything about that?
No idea.
No idea.
Although, so basically, WebGPU being, and somebody can prove me wrong here. I'm not an expert in this stuff. I just heard about this in passing mainly, but I've seen some end results of what you can actually do, and it's very impressive. But I'm definitely not a graphics programmer, so I don't know much about the topic itself. But I know for sure that integrating any sort of call it like a module, I guess, right? It module in the sense that everything in WASI will be like a library or a binary, but then we call all those modules, I guess. I think the general idea is that it has to be as easy as possible for anybody to actually take something like WebGPU and integrate that with WASI. So you should be able to write your own, I guess, syscalls. Think about it this way. They can then load up as like basically linked to in your runtime, and then you can have an app that actually makes use of that.
Final question. Is WASI related to formalizing marshalling data structures from WASM to JS and or other languages?
WASI itself, no, but it will be making heavy use of this stuff. So I think this technically is called interface types, because as far as I know, we're quite limited at the moment to passing basically integers, which is not ideal. Or basically pointers and lengths for actually passing strings, which is very annoying. It's the C style. But the idea is that interface types will streamline this so that you can actually pass anything, and the runtime will be smart enough to work it out for you. And if anybody's interested, I can send some links. I'm pretty sure I have them somewhere in this massive pile of all the documents.
Okay, that's awesome. Well, I do recommend that if you want to continue the discussion moving forward, take a look at the communities on ziglang.org. And I believe, Jacob, you are in the Discord server, right?
Yeah, that's true. Yep, that's right.
So, for example, that's one good way of doing so. Thank you very much. That was an awesome session. Really awesome.
Thank you.
So,
thank you.
Is there anything else that you want to say before we move forward?
Not really. I enjoyed it. Hopefully I enjoyed, like, you guys enjoyed it as much as I did. So I enjoyed it immensely, actually, giving this talk. So, and if you did, I'll be happy to actually do a couple more on different bits about WASI and stuff. So.
Absolutely. So, okay, we can now move to the break.